So although there's 7 base units, we only talk about 5 specifically. So I'm just going to give you those 5. There's a couple on here that we don't deal with, which is the intensity of light and the intensity of sound. We won't talk about those 2. So I'm going to give you 5 of the 7. When we think of length in U.S. measurements, what do we think of? Inches, feet. What's longer than a foot? A yard, and then a mile, right? There's so many different ways for us to measure length that it just depends on the amount of length you're measuring, right? Which is silly. So the US, or the metric system, it gives one base unit or one unit, and then it bases prefixes off of that unit. Okay, so we have meters and centimeters and millimeters and kilometers and megameters, right? Those are all versions of a meter. All they're doing is adding a prefix to it. So that the way that they label their measurements are much easier, right? So that's the same across all of these things. Those prefixes that we're going to talk about, have you heard those before? Centa, milli, deci, right? We've heard those before, hopefully. Those are all prefixes that have to do with the metric system, and they do with length or mass or height or whatever it is, okay? So the base unit, which most things are measured in length, is meter. The base unit for mass is technically a kilogram, not a gram. Okay, if I'm talking about the base of the prefixes, it's still a gram, right? But what's most commonly measured is a kilogram. Does anyone have any idea why that might be?
Because most things are more kilogram than gram.
That's right. Most things that we're going to measure have a mass of greater than 1,000 kilograms. Okay, and 1,000 grams. 1,000 grams makes a kilogram. So rather than measure things in the 10,000s, right, we measure it on a smaller number, and we measure it in kilograms instead. Okay, so if we're talking about the base unit of our prefixes, right, kilo, then whatever the base is, then deci, then centa, then milli, right, we're talking about that. The base unit would be gram. Okay, but the most commonly measured unit for mass is kilogram. Okay, time is going to be in seconds, which is a little unusual for us, right? It's a little strange for us to measure things in seconds rather than minutes or hours. But time is, the same throughout all countries. That doesn't matter. Seconds is going to be the most used for scientific purposes, right? We don't measure things in hours long worth of time. Usually seconds. Temperature is Kelvin. Have you worked with Kelvin before? Not a little bit? Some of us are saying no, some of us are saying yes. Okay, Kelvin is a temperature unit that's used specifically for science, right? It's most commonly used for science. Celsius is the other one. So Fahrenheit, which the U.S. uses, is the least commonly used for science. So we will deal almost exclusively with Celsius and Kelvin, and there's a really easy conversion from Celsius to Kelvin, and we'll talk about that. Okay, and then the amount of substance is called a mole. So the mole we'll get into next chapter a little bit more, but that's basically the 5 big units that we're going to talk about. Okay, here's our metric system prefixes, and so some of you have probably learned this via like a stair-step system. Okay, does that sound familiar? Some of you have learned it that way. That's fine if you want to remember it that way. I've kind of written up a new table that makes the most sense to me. Okay, and what this table is saying is basically, here's the base right here. So here's where regular meter or gram or liter, or whatever the regular unit is, that's where it goes. Any prefix above that is larger than that base unit. Any prefix below is smaller than the base unit. Okay, so a centimeter is smaller than a meter, right? A millimeter is smaller than a meter, all those types of things. So I've given you an example over here. And I've put it in meters, okay? It doesn't have to be meters. It could be grams or liters or seconds or any of those metric units. Does that make sense? Okay, give me just one more second to explain here why I put this table the way I did. Okay, so in this last column, what I did was I always gave the larger unit the 1. Okay, so since I know a megameter is larger than the base, I'm saying 1 megameter is equal to 1 times 10 to the 6th meters, or 1,000,000 meters. We're going to talk about scientific notation a little bit more too, because I know some of you are a little unfamiliar with scientific notation. But this is basically equal to 1,000,000 meters. Okay? If I step down to kilo, I gave kilo the 1 because it's the bigger unit. So I'm saying 1 kilometer is equal to 1,000 meters. Okay? This for me is easier than saying the reverse of that, which would look like this. We could also put it like this. We could say 1 meter is equal to 1/1000th of a kilometer, right? Rather than deal with decimal places, I like to just give the bigger unit the 1 and I give the smaller unit the however many smaller units go into the bigger. Okay, does that make sense or not so much? Okay, so below that everything's equal to a meter because that base unit is above those prefixes. So I'll give you some time to get this written down and then we'll do some practice with them. Okay, so let's try one here. Actually, I don't know if we're going to try one just yet. Okay, so we looked at units for simple measurements, length, mass, volume, things like that. Now if we were looking at the area of something, how is it that you go about finding the area of something? Like let's just say a square or any sort of quadrilateral. How do you find the area? Yeah, length times width. Okay? So that means if this side is 6 meters and this side is 4 meters, I'm taking 6 meters times 4 meters, which gives me 24 meters squared, because I took my unit times my other unit. Okay, so this squared has nothing to do with the number. Okay, it only has to do with the unit. Does that sound familiar? Did you guys use units when you did area in math? Sometimes? Maybe? Okay. So that squared unit has nothing to do with the number. It has to do with the unit itself, right? So when I take, just like if I was doing this, 4x times 3x, right? What would the product of that be? 12x squared, right? That x is just like our unit, right? So that's all we're doing there. That's where that meter squared comes from. Volume, we said, was measured in liters. It could also be measured in milliliters, depending on how big of a volume we're talking here. But a conversion that you should write down is 1 milliliter is equal to a cubic centimeter, okay, or centimeters cubed. That's one that we'll use pretty often. So that just means literally 1 milliliter is equal to 1 cubic centimeter. Temperature, if it's not measured in Kelvin, most of the time it will be measured in degrees Celsius. Here's something that we should point out for temperature. We talk about degrees Fahrenheit, degrees Celsius. Do we talk about degrees Kelvin? No, what is it? It's just Kelvin. Kelvin doesn't have a degrees attached to it. I don't really know why. But it doesn't. So when we're talking about Kelvin and we're talking about a temperature, we're saying it's 400 Kelvin or 200 Kelvin or whatever it is, but it's not degrees Kelvin. It's just a little something. Okay. Here's how you convert now from Celsius to Kelvin, and this conversion is our simplest one. We want to go from Celsius to Kelvin. We're going to add 273. That's it. So that means if I wanted to go from Kelvin to Celsius, what would I probably do? Yeah, that's right. All I would do is subtract 273. I would reverse that conversion. Okay? So if I want to go from Celsius to Kelvin, I add 273. If I want to go from Kelvin to Celsius, I subtract 273. Okay? So that means if my temperature was 0 degrees Celsius, which is the freezing point of water, what would my temperature be in Kelvin? Yeah, it would be 273. If I was 100 degrees Celsius, what would I be in Kelvin? 373. Okay, so that conversion is very simple. All we're doing is adding that. That's something that you might want to highlight or put a little star by or something. That is something that you will need to know how to do. Okay. Little information I'm going to give you today, kind of before we start doing some practice, is our conversions from US units to metric units, or SI units. Okay? SI stands for System International. And we commonly just call it the metric system. Okay, but SI stands for System International. Okay, and so these conversions get us from the US system to the metric system, or the SI system. Okay, so this is the last big table you'll need to put in your notes before we start doing some practice. Those three that I have stars by are the ones we'll use the most often. Okay, so you might just want to star those so you kind of know where they're at. Okay, so let's look at what's the reason that we're looking at units so much, and what's the reason we're looking at conversion of units. Okay, carrying units throughout our entire problem is extremely important. So if we start our problem with something in meters and we need it to end up in centimeters, we have to know what we're doing our math in. Right, we have to know what we're working with. So keeping our units throughout our whole problem is really important, okay, especially as we get into conversions here. If we don't carry our units, if we drop our units, then if we give a number at the end, we don't have any idea what that number is telling us. Right? So if we're asked, how long did it take? What do you think we're trying to measure? What do you think we're trying to get our answer in? We asked, how long did it take? Yeah, it's a time measurement, right? That means our units need to be seconds. If we ask, how much did it weigh? Or what was its mass, right? It's got to be some version of a gram. Maybe it's a kilogram, a centigram, milligram, whatever it is. But if we don't keep those units, we don't have a complete answer. Okay, so units are really important. Without units, our measurements make no sense. So we can't have any plain numbers. Okay, you don't have to write all this down. We're just thinking about this in terms of when we do these problems, we can't have plain numbers. It has to have units with it. Okay, All right, let's go ahead and try some now. So I'm going to show you my method for unit conversions. Okay, and my method is called a T-chart. Okay, and this T-chart method allows us to convert multiple times in one step. Okay, so we're not doing 3 different problems. We're just doing one, right? We're plugging things into an equation essentially, or a little chart, and then we can multiply it one time and divide it one time. So we're not doing math multiple times. Does that make sense? Okay, so let's think about if I want to go from milligrams to kilograms, can I go directly there? Or where should I kind of stop in the middle? Go ahead and look at your chart. Do we have a conversion that says this many milligrams is equal to this many kilograms? Do I have any direct conversion from milligrams to kilograms? No, right? Nowhere in your chart does it say 1 kilogram equals, 1,000 milligrams. That doesn't say that, right? So where should we go in the middle? Any ideas? To what? To grams. That's right. Grams is our middleman, right? Just like meters would be our middleman, or liters. Whatever the base is in that chart, that's kind of our middleman, right? Because everything can be led back to that. So our order here, we need to go from milligrams to grams and then to kilograms. Okay, so let's think about how we do that. This is the T-chart system. And the T-chart system always starts by writing what we know. So I'm going to write 142.2 milligrams. Okay, so first step is always writing what we know, and then we draw our T-chart, kind of a sideways T-chart. Okay, this is how we start it. Every time we need to convert. Write what we know, we draw the T-chart. Okay, T-charts can be multiple steps, or they can be one step, doesn't matter. Okay, it will always work this way. So I need to go from milligrams to grams. Is that correct? Is that what we decided? Then from there, we'll go from grams to kilograms. So let's take it one step at a time. In normal multiplication and division problems, if I want something to cancel, where do I need to put it? I need to put it opposite of its starting point, right? More specifically on the bottom, right? If it starts out in the numerator, I need to put it in the denominator to get it to cancel, right? And we're talking like in ratios and all that kind of stuff. Is that coming back a little bit to us? If I want to cancel it, it's got to go down on the bottom. So I want to get rid of milligrams, so it goes opposite, right? Diagonal of where milligrams started. And I want to go 2 grams, so grams goes on the top. Okay? That's the first section of my T-chart. Okay, so I can draw my line. We're going to go ahead and plug in our numbers here. So let's look back and decide which of those units is bigger.
Kilograms.
Just between these two, sorry. Grams is bigger, so grams gets the 1. Okay, and then we're going to tell how many of the smaller unit will fit into 1 gram. Once we write this original number, we don't care about it until we go to do our final math. So we're only looking at this section of our T-chart right now. Okay, we're not trying to do any math in our head. We're just looking at how many milligrams can fit in 1 gram. One more 0. 1,000. Okay, look back on your chart. Does that match? 1,000 milli in that base. I know we wrote it in meters in our example. It works for every type of metric unit. Does that make sense? Okay. So now we've canceled milligrams. So I'm going to go ahead and cancel those units so I know that we're done with milligrams. And right now we're left in grams. Is that where we want to be? We want to be in kilograms. Okay, so we're going to do the same thing. I want to get rid of grams. Where does it need to go? On the bottom, right? It's got to go opposite of where it started. And I want to go 2 kilograms. Okay, so now again, I'm just looking at this section of my T-chart. Between those 2 units, which is bigger? A kilogram. Okay, and how many grams are in 1 kilogram? 1,000. Okay, so now I go back and I check my units. I got rid of grams. I got rid of milligrams. So that means right now if I did my problem, I would be left in kilograms. Is that what I want? Yes. Okay, so here's how this problem works. It's basically a big multiplication and division problem. You multiply across the whole top, and then you divide by the whole bottom. Okay, multiply across the whole top, divide by the whole bottom. So let's work this out in our calculator. 142.2 times 1 times 1, right? That doesn't, you don't even have to do that. 142.2. On the bottom, we need to be careful when we divide by the bottom. It's either divide by 1,000, then divide by 1,000 again, or it's 142.2 divided by parentheses 1,000 times 1,000. Okay, we have to be really careful when we put that into our calculator. Because if we do 142.2 divided by 1,000 times 1,000, with no parentheses, no nothing, those 1,000s are just canceling out. We're going to end up with 142.2 again. Okay, so when I did it in my calculator, I got 1.422 times 10 to the negative 4th. Okay, or E negative 4. Okay, not what we got?
No,
Okay, answer to be complete.
kilogram.
We have to write kilograms.
It must be on the outside of
The parentheses mean nothing. Sorry, the parentheses mean nothing. Okay, those, I was just talking about scientific notation. Those don't mean anything. Okay. So either way, we can express this answer as a decimal or in scientific notation. If you're not comfortable with scientific notation yet, that's okay. We'll get there. Okay. But this have to have kilograms. So what questions do we have right off the bat? So we're going to do a bunch of practice here just with metric system today. We're not going to do US to metric system yet. Okay, we're going to do just metric system today. 0.48 kilometers. What's the first step in every T-chart? Write what you know. That's right. Write what you know. Okay, and we happen to know that we have 0.48 kilometers. Okay, and then we draw our T. Is there a direct conversion for us to go from kilometers to centimeters? No. So what's our middleman? What do we stop at? We go to meters, and then we can go to centimeters. Okay, does that part make sense? Whenever you're in doubt, just go to the base unit, and then you can go to what you need to next, right? Because we always have a conversion to the base. So if you're confused about like how we should go from one to the other, just go to the base unit and then go back to whatever you're trying to get to. Does that make sense? So you're not trying to move decimals or do anything crazy. That will always work. Okay? So we need to go kilometers to meters. Okay? So if I want to get rid of kilometers, where does it go? The bottom, right? It goes opposite of where we started because we want these to cancel. And we said we wanted to go 2 meters. Okay, then I draw my T. Okay, so looking only at this section of our T-chart here, we talk about which is the bigger unit. Yep, good, kilometers. So it gets the 1. That's okay, you can say it either way. How many meters are in a kilometer? 1,000, good. 1,000. Are we seeing that in our chart? Okay, can we navigate our chart to find those two things? Okay. So now, if I look at my units, I'm done with kilometers because I've multiplied and divided by it, right? Let's think if the whole top's multiplication and the whole top's division, we can stop there. But we're at meters. Is that where we want to be? No. So we don't do any math until our T-chart is complete. We don't need to plug anything into our calculator yet because we're not done yet. So if I want to get rid of meters, it goes on the bottom. Centimeters goes on the top. Okay, looking at just this section of our T-chart, which is the bigger unit, meters, and centimeters, there are how many centimeters in a meter? 100. Okay. So I'm done with meters. I'm left in centimeters. Is that what we want? Yes. Okay, so now we've double checked all of our units. We're left in centimeters. Now we do the math. Okay, we multiply across the whole top, divide by the whole bottom. This one's really easy, dividing by the whole bottom, right? Because it's just ones. So all we're doing is multiplying the top. So 0.48 times 1,000 times 100. 48,000. What's our units? Centimeters. Our units are always going to just go opposite of where we start. So we want to get rid of nanometers and go to what goes on top right here, right on top of nanometers. Meters, good. Okay, so you tell me which of those is the larger unit? Just regular meter. So if look back at your chart, we gave the larger unit the 1. Right? So in your chart, when we're looking at that, if you can't decide, right, we gave the larger unit the 1. So we said 1 meter is equal to a billion, I think, nanometers. Okay? So meters gets the 1. And we say there's 1 times 10 to the 9th nanometers. So let me put times 10 to the 9th. That's how many nanometers are in a meter. Okay, so I think that's 1 billion. That's a lot, right? And I know we're not super familiar with scientific notation, so that's what that's saying. 1 times 10 to the 9th, that's how many nanometers are in a meter. Okay, so nanometer is an extremely small unit. It's 1 billionth of a meter. Okay, so here's a meter, right? A nanometer is 1 billionth. We can't even see that on here. Okay, so it's a really, really small unit. Does that make sense? Okay. So cut that into a billion. That's 1 nanometer. Okay, we canceled nanometers. We're left in meters. Is that where we want to be? No. We want to go to kilometers. Okay, which of those units is the larger unit? Kilometers. And we say there's 1,000 meters in a kilometer. Okay, so I'm going to check my units again, make sure they all canceled. Okay, if they're not opposite of each other, we're going to have math problems. Okay, we want them to make sure that they are opposite. We also understand that kilo means 1,000, but it doesn't mean that there's 1,000 kilometers in a meter, right? Make sure we get that conversion correct. Okay, so let's go ahead and plug it into our calculator and we see how we do, because I'm worried about how we plug in with scientific notation. So try your best, see what we get, and I'll tell you what we should get. Okay, we're going to do the one on the bottom. Milligrams to megagrams. Okay, so milligrams. What's going to be our middleman here? Can we go directly from milli to mega? So what's our middleman here? Just grams. Good. So we want to go milligrams to grams. Okay, which of those gets the 1? Grams. Good. Grams is the bigger unit. And how many of those milli are in grams? 1,000. Good. Okay, so I'm checking my units. I've canceled those, which is good. Now I want to go grams to megagrams. Which of those unit is larger? Mega. So mega gets the 1. How many grams are in a megagram? 1 times 10 to the 6th, or 1 million. Okay, that was the top one on your chart. Mega was the biggest one that we learned. Okay, and that's the capital M. There's lots of prefixes that start with M, right? Regular lowercase m is a meter. That's not a prefix. It's also milli, which is the prefix. That's a little tricky. Okay, but mega is the capital. So we're done with grams. We're left in megagrams, which is what we want. So let's do the math. Okay, you're going to have to use that E button on this part of your division problem. Okay, so if I'm plugging it into my calculator, I'm doing 32 divided by 1,000 divided by 1 second, EE to the 6, positive 6. Okay, that's fine. As long as there's 7 zeros before that 3, you're good to go. Okay, yep. Some calculators put them in scientific notation automatically, some don't.
You can set the calculator.
Yeah, you can. You can. You're right. That's all right. You do want to do it or you don't want to. It doesn't matter. If you want to, I think it's just one of those top buttons on that little calculator, right, Evan?
Yeah, it's right next to the second button.
Okay, so you can set it there either to scientific or English or something. Okay? Are we getting that to come out okay? All right, are we ready to try one on our own? Sure? Okay. 3.2 times 10 to the negative 8 megagrams. Let's try one on our own here. Yep.
If we wrote like E as an answer.
That's fine. I don't love it, but I would take it. I usually like to write times 10 to the, but I mean, I'll take it. I just don't love it. All right, let's try this one. We're going to go 36 micrograms to centigrams. Micrograms to centigrams. So we haven't done one like this yet where they're both below the base. Okay? But instead of trying to figure out how many decimals are between them, we're still going to go to the base and then go back. Okay? So still you're doing the same thing. We're going to go to grams and then to centigrams. Okay, so you're not changing the way you do it. You're just not going to have both of those small units on the bottom or both on the top. We're going micro. This is micro. Just try your best. I'm going to come around. I'll be walking around. You can let me know if you need help.